that is values. It is nothing but a sequence of characters, you know, character string. Some of the languages does not support this type, but these are very useful because output of all kind of data are often done in terms of strings. So there are some design issues also. Two most important design issues are there, specific to your character string type, that are the string should be simply a special kind of character array or a primitive type, and it should be the strings have static or dynamic length. Okay, so these are the design issues. Then character string types operations. There are some operations that we can perform with the character string, that is assignment and copying, comparison, concatenation, substring reference, then pattern matching. Some languages are having directly the functions relevant to these operations. Okay. So character string type in certain languages, in C and C++, not primitive. So for that we have to use the char arrays and a library of functions that provide the operations. Okay. Then Snowball 4, it is a primitive one, and many operations including elaborate pattern matching also there. In Fortran and Python, primitive type with assignment and several operations are provided. In Java, primitive via the string class. In Perl, JavaScript, Ruby and PHP, they provide built-in pattern matching using regular expression. So various languages used either primitive one or non-primitive one. Then character string length option. So for static, COBOL and Java string class we used limited dynamic length in C and C++. In these languages, a special character it is used to indicate the end of the string's character rather than maintaining the length. Okay. So the dynamic, Snowball, 4, Perl, JavaScript, then add supports all three strings length options. In character string type evaluation, aid to writability. Then as a primitive type with static length, they are inexpensive to provide. Dynamic length, it is nice, but it is worth the expenses. Character string implementation, static length is there. Compile time descriptor, limited dynamic length, may need a runtime descriptor for length. So dynamic length need runtime descriptor, and allocation and deallocation is the biggest implementation problem. So this is relevant to your character string implementation. So sometimes character string types are not directly supported by the hardware. So in such cases, software is used to implement the string storage, retrieval, the manipulation. Okay, so a descriptor for a static character string type, which is only required during the compilation, has three fields: static string, length and the addresses. And the limited dynamic streams require the runtime descriptor to store both the fixed maximum length and the current length. That is limited dynamic string, maximum length, current length and the address. So for example, over here you can see this is a compile time descriptor for the static string, and the other diagram shows the runtime descriptor for the limited dynamic string. User-defined ordinal types. An ordinal type, it is one in which the range of possible values can be easily associated with the set of positive integers. For example, in Pascal and Ada, integer, character and boolean, they are primitive ordinal types. So in many languages, user can have kind of ordinal types, that is enumeration and subrange. So examples of primitive ordinal types in Java, that are integer, character and boolean. Then we are going to move further, that is enumeration types. So all possible values which are named constants are provided in the definition. C sharp example is there: enum days, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Okay, so this is the enumeration type example. It is one in which all the possible values become symbolic constant. Okay, these are the symbolic constant. So there are some design issues also. So in an enumeration, constant allowed to appear in more than one type of definition, and how it is the type of an occurrence of that constant, checked or unchecked. So are the enumeration values codes to integer? Any other type codes to the enumeration type? Okay, so these are the certain design issues relevant to your enumeration types. So in Pascal, C, C++, the literal constant is not allowed to be used in more than one enumeration type definition. So enumeration type variable can be used as a array subscript, for loop variable, case selector. Okay, so two enumeration type variables of the same type can be compared with the relational operators with their relative position in the declaration. So the enumeration types of ADA language are similar to those in Pascal, except that literals are allowed to appear in more than one declaration in the same referencing environment. So this is called as actually overloaded literals. Then we will move ahead, that is some subrange types. So subrange types were introduced by the Pascal, and they are used also in ADA language. So a subrange type, it is a contiguous subsequence of the ordinal type. For example, see an ordered contiguous subsequence of ordinal type. Example is given 12 dot dot 18. It is a subrange of integer type. Meaning is what? It will include from 12, including 12, up to 18. Okay, means 12, 13, 14, 15, 16, 17, 18. So ADA's design, in ADA's also see type days is, and we have mentioned the days over here. So subtype weekdays is days range from Monday dot dot Friday. Subtype index, it is integer range from 1 dot dot 0. Okay, so how it will work? Day 1, days, day 2, weekday, day 2 is equal to day 1. Okay, so likewise it will include. Okay, so in this example, the restriction on the existing types is the range of the possible values, and all the operations defined for the parent type are also defined for the subtype except the assignment. Okay, so the assignment, it is a legal unless the value of day 1 is a Saturday or Sunday. Getting? So how they are going to evaluate the subrange? So subrange types enhance the readability by making it clear to reader that variable of subtype can store only certain range of the values. So also because of assigning a value to a subrange variable that is outside the specified range, it is detected as an error. Then subrange evaluation, we have seen that it is readability and reliability. Implementation of user-defined ordinal type, that is enumeration types are usually implemented by associating a non-negative integer value with each symbolic constant in the type. So operations allowed are dramatically different from those of the integers except for the relational operators, which is identical. So subrange types are implemented in the same way as their parents, except that the range check must be implicitly included by the compiler in every assignment. Now we are going to see array types. What is array type? Already we know array, it is a homogeneous aggregate of data elements in which an individual element is identified by its position in the aggregate relative to the first element. So a reference to an array element in a program often includes one or more non-constant subscripts. So such references require a runtime calculation to determine the memory location being referenced. So the individual data element of an array are of some previously defined type, either primitive or otherwise. Then there are certain design issues relevant to array. They are as follows. What types are legal for subscript? Are subscripting expressions in the element references range checked? When are subscript range bound? When does array allocation take place? What is the maximum number of subscript? Can array objects be initialized? Are any kind of slices supported? So these are the all design issues relevant to your array. So we are going to see array indexing. You know all indexing, or it is also called as subscript. So it is the mapping from the indices to the elements. So if you want to access a certain element, array element, then you have to mention the index. For example, array name, and we can mention over the index value of that. And it will point out to an element. So index syntax is different in different languages. Fortran, Ada use parenthesis. Ada explicitly uses parenthesis to show uniformity between the array references and function calls, because both are mapping. Most other languages are use brackets. So in different languages we use different syntax. So there are array index types also. Fortran and C, integer we have used. Then in Ada, integer or enumeration we used. In Java, integer types we used. Then in C, C++, Perl and Fortran, we do not specify any range. In Java, ML, C# specify range checking. In Ada, the default is to require range checking, but it can be turned off. So subscript binding and array